Welcome to the Health Headliner podcast by Tudu Digital. Our content is informational only and not medical advice. Please consult your provider. Now, let's dive into today's headlines.
Ever notice how your heart just seems to pound a little faster on a really hot day, even when you're just chilling?
Oh, absolutely.
It's like your body's working overtime, right?
Yeah.
Just to keep you cool.
Yeah.
So today, we're going deep, really deep, into how heat affects your heart, specifically in those acute, immediate moments.
Right.
You found some fascinating research for us to dig into. There's this one study, well, actually a meta-analysis that combined the results of over 400 scientific studies.
Yeah.
All about this topic.
Wow.
Pretty intense, huh?
Yeah, that is a lot.
So let's really unpack what this tells us about how our hearts react in the heat. Like what actually happens when the temperature climbs.
Well, the fact that it's a meta-analysis right from the start, that's huge.
Yeah, it is.
It means we're not just looking at one isolated experiment. We're getting the combined knowledge of hundreds of studies. In this case, the researchers compared all sorts of different ways of heating people up in a lab setting, and they looked at how it affected their heart rate, their cardiac output. That's how much blood the heart pumps out with each beat.
Okay.
There's systolic blood pressure. That's the top number in a blood pressure reading. And then something called the rate pressure product.
Oh, interesting. Rate pressure product.
Yeah, it's basically a measure of how hard your heart is working.
Oh, okay, got it.
Like, think of it like how much effort a car engine needs to go a certain speed. The higher the rate pressure product, the more your heart is straining.
I like that analogy. That makes it super clear.
Yeah.
So the goal today in this deep dive is to break down all of this data. Like, what's the big takeaway? What happens to your heart when it gets hot?
Exactly. This research really focuses on those immediate effects.
Right, right. And to be clear for our listeners, we're mainly looking at this one major scientific paper, a meta-analysis, which means they took data from a ton of other lab-based studies. So it's not just one little experiment. It's a big picture view.
Yeah, exactly. And that helps us see the bigger trends, right? And compare the different ways scientists have been studying heat exposure.
Right, perfect. So let's dive into the study itself. What was the main thing they wanted to find out?
Well, like we've touched on, they wanted to compare the different ways of heating people up in the lab, and they wanted to see how that affected their heart rate, their cardiac output, their systolic blood pressure, and that rate pressure product.
Got it.
But the big question was, do those findings in the lab actually reflect what happens in the real world? Like when you're just out and about on a hot day or, during a heat wave.
Right, because the lab is a controlled environment. But real life, it's real life.
Exactly.
So how did they even go about doing this analysis? Like, what was their process?
Okay, so get this. They analyzed 400 individual studies.
Wow.
Can you believe that? 400.
That's incredible.
And those studies contributed to 586 different effect estimates, and it included data from over 6,800 participants who were exposed to heat.
Wow, that is a lot of data.
It is. It's like analyzing a whole year's worth of heat exposure for one person.
Seriously.
And they used all sorts of methods to heat people up. There were climate-controlled chambers.
Okay.
These chambers are designed to mimic real-world weather. They also used water-perfused suits.
Water-perfused suits, what are those?
They're these garments, like a suit, with tubes that circulate hot water.
Oh, okay.
So it raises your body temperature really quickly in a controlled way. They also looked at hot water immersion, basically like sitting in a really hot bath.
Yeah.
And they even looked at saunas.
Wow, so a really diverse range of ways to heat someone up.
Totally. And they compared how these different methods affected heart rate and all those other cardiac measurements as the participants' core body temperature rose.
Okay.
But they didn't stop there. They also factored in a bunch of other things that could have influenced the results.
Like what?
Like how much the core temperature actually increased, how it was measured, like was it taken orally or rectally?
Makes sense.
What position the person was in during the heating. Were they sitting, standing, lying down? And then things like the insulation of their clothing, their age, their sex, their body mass index, even the climate zone where they normally lived.
Oh, wow. So they really tried to cover all the bases.
Yeah, they were super thorough. And then, because sometimes multiple data points came from the same study, they used special statistical models to account for that.
To make sure the results were accurate.
Exactly. So what did they find after all that? Well, first, no surprise here, heart rate went up when people were exposed to heat.
Makes sense. That's what we feel, right?
Yeah. But here's where it gets interesting. They found that the way people were heated up actually made a difference in how their heart responded.
Interesting.
So those water-perfused suits, they're great for controlling temperature, but they caused much bigger increases in systolic blood pressure and that rate pressure product compared to when people were heated in those climate chambers. And this was even when their core body temperature went up by the same amount, like 1 degree Celsius.
So the method of heating really mattered.
It did, and we're talking clinically significant differences here. Like, the difference in systolic blood pressure was more than 10 millimeters of mercury.
Wow.
And the rate pressure product difference was huge. Over 1,800 millimeters of mercury times beats per minute. That's more than what doctors would usually consider worrisome.
So just changing how someone is heated can really impact their heart.
It can. And get this, when they tried to adjust for things like posture and clothing, it didn't really change the differences in heart rate between those two heating methods.
Interesting.
But then they factored in skin temperature.
Oh, skin temperature.
Yeah, the average skin temperature at the end of the heat exposure. And when they did that, the differences in heart rate between the heating methods, they weren't statistically significant anymore.
So skin temperature is key.
It seems to be. And for every 1 degree Celsius increase in average skin temperature, heart rate went up by about 2 beats per minute.
That's pretty significant.
It is. It shows how important what's happening at the surface of our body is, for how our heart reacts to heat.
Makes sense. It's all connected. Now, what about those other methods, like the hot baths and saunas? What do they find there?
Well, with the hot baths or hot water immersion, they actually saw smaller increases in heart rate.
Oh, really?
But the cardiac output was higher.
So the heart wasn't beating faster, but it was pumping out more blood with each beat.
Exactly. And they think that's probably because of the water pressure, like the hydrostatic pressure of the water kind of helps push blood back towards the heart.
So the water is lending a hand, so to speak.
Exactly. And with the sauna studies, there were some differences in how systolic blood pressure responded.
Oh, how so?
Well, in the climate chambers, systolic pressure usually went down as core body temperature increased.
Okay.
But in the sauna studies, it went up.
Interesting. So, again, the type of heat exposure really does matter.
It does. It affects the heart in different ways. And that leads us to some important implications for, how we think about heat in the heart outside the lab.
Okay, let's talk about those implications. What does all this mean for us in the real world?
Well, one big takeaway is that those super intense heating methods, like the water-perfused suits, they might be overestimating how much strain our hearts actually experience in normal hot weather.
Okay.
Because in real life, our bodies can cool down more effectively, through sweating.
Yeah.
And as we saw, skin temperature is really important. Those suits get the skin super hot, which seems to be a big reason why they see bigger cardiac strain in the lab. But when we sweat and that sweat evaporates, it cools our skin down, so we might not reach those same extreme temperatures.
Right, sweating is like our built-in AC system.
Exactly. And because of all this, the researchers are saying we need more studies that are done in real-world conditions, like outside the lab.
Makes sense.
To really understand how heat affects the heart in those everyday settings. They even included some of their own data from climate chambers where they tried to mimic conditions similar to deadly heat waves, which is a good step in that direction.
Yeah, studying heat in environments where people actually live and work.
Absolutely. And another thing they found was that when they looked specifically at those climate chamber studies, the higher the heat index, the bigger the increase in core body temperature and heart rate, especially at those really high levels of heat stress.
But the hotter and more humid it is, the harder our hearts have to work. Now, of course, we should talk about the limitations of this study. What did the researchers point out?
Well, even though they tried to account for so many things, there was still some variability in the results, like how people responded to heat was still different even when you controlled for all those factors.
Just individual differences play a role.
Definitely. And most of the studies were done on younger to middle-aged adults, mostly men, and most of them didn't have any chronic health conditions. So we need more research on older adults, people with health issues, and how heat affects them specifically.
Makes sense. Different people, different responses.
Exactly. And then for some of the measurements, like cardiac output, there wasn't data in every study. And even when there was data, they sometimes used different methods to measure it. So there's some uncertainty there.
So the findings for those specific measurements might not be as clear-cut.
Right. And they also mentioned that most of the studies were done in North America, Europe, and Japan. So the results might not apply to people who live in really hot climates, places that are facing the most severe effects of climate change, because they might have adapted differently to the heat over time.
Right. Their bodies might react differently.
Exactly.
So to be clear, the researchers themselves, with all this analysis, they're basically giving us their expert opinion, right?
Yeah, they are. They've looked at hundreds of studies, so they have a really good grasp of this topic.
So what's their main takeaway, their expert conclusion?
Basically, they're saying those lab studies with the intense heating methods, they're good for understanding how the body reacts to heat, like the mechanisms involved.
Okay.
But they might not be accurate when it comes to how much strain our hearts experience in normal, everyday heat.
So good for the how, but not necessarily for the how much.
Right. And they really stress that skin temperature is super important.
Yeah.
They think it's often overlooked. And those high skin temperatures in the lab, they might be exaggerating the effects on the heart.
So a more nuanced view of how heat affects us.
Exactly. It's not just about your internal temperature. It's about what's happening on the surface, too.
It all works together. So what's the big final thought you want to leave our listeners with today?
I think the main point is that how we study heat really matters. It shapes what we learn about its effects on the heart. And that makes you wonder, what other assumptions do we have about climate change and health?
Interesting.
What else do we need to re-examine?
Yeah, good question.
And I think it also highlights how complex our bodies are.
Right.
Our response to heat is so intricate. It's not just one thing, it's a whole system working together.
A beautiful, complex system.
Exactly. And maybe next time you're out on a hot day, you'll pay a little more attention to how your body is reacting. Not just the heat, but how your skin feels.
Yeah, it makes you think. Thanks for this deep dive. It was really eye-opening.
My pleasure. It's always fascinating to explore these topics.
Thanks for tuning in to the Health Headliner podcast by To Digital. Like and subscribe for more health news and breakthroughs. Stay healthy and informed. See you next time.